This is a sum of online maths, and in this lesson, we shall solve the 2024 WAEC objective questions from number 1 to 4. After 1 to 4, we will solve 5 to maybe 9, and so on and so forth in that order. So the first question says that we should multiply 3.4 times 10 power minus 5 by 7.1 times 10 power 8 and leave our answer in standard form. So when you have 3.4 multiplied by 10 to the power of minus 5, then times 7.1 multiplied by 10 to the power of 8. The best thing to do here is to make number be with number. Sorry, make the basis be with the basis and the power be with the power. So we can call this 3.4 multiplied by 7.1, then times 10 to the power of minus 5 multiplied by 10 to the power of 8. So when you say 3.4 times 7.1, that will give us 24.14 times 10 to the power of minus 5 plus 8. I am adding the powers because from indices law, when you have terms with the same basis and you are multiplying, you simply have to add the powers. So this will now be 24.14 times 10 to the power of minus 5 plus 8 is just 3. But this is not yet in standard form. It can only be in standard form if this if this decimal point is moved here to appear after the first number. And when you make the movement, you have 2.414 times 10 power of, because you've decreased it by making one movement, increase the power by 1 so that the power is now 4. So this is the right answer to the problem number 1. We go to number 2. Number 2 says that given that P, the set P is equal to P such that 1 is less than P and P is less than 20, where P is an integer. So let us find the elements of P, numbers between 1 to 20, meaning that 1 and 20 are not inclusive because of this strict inequality. So the numbers can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. These are the elements of set P. Then for set R, we are told that set R is equal to R such that 0 is less than or equal to R. Less than or equal to means, because of this line, that 0 is inclusive. And R is less than or equal to 25, where R is a multiple of what? 4. Multiples of 4. Multiples of 4 are those numbers you can get by multiplying 4 by an integer. 4 times 1 is 4. Even if you like, you can include 0 because many can argue that 0 can be a multiple of 4 because 4 times 0 is 0. So even if you include 0, it won't still affect the answer. 4 times 2 is 8. 8 times 2, 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. 4 times 6 is 24. But you cannot exceed 24 in the sense that it is less than or equal to 25. The next number should be 28, next multiple of 4. But 28 is not part of the set R. And our target is to find P intersection R. P intersection R is simply those elements you see in P that you can also see in R. That's the meaning of P intersection R. So what are the elements in P that are also in R? 4. After 4, you have 8, 12, and 16. Okay, so let's go to the third one. First term of an arithmetic progression is 2. First term is A, meaning that A is equal to 2. And the last term is 29, right? Last term is equal to 29. Remember that the last term is the same thing as the n term. Okay, if the common difference is 3, so our D is equal to 3. How many terms are in the sequence? We are looking for the number of terms in the sequence. Remember that the nth term of an AP is A plus bracket N minus 1D. And the last term is 29, so always equate with the last term. Our A is 2, so put 2 for A, plus number of terms we don't know, we are looking for it, minus 1, multiply by the common difference of 3, everything is equal to 29. So you have 2 plus 3 times n is 3n, 3 times minus 1 is minus 3, everything is 29. So this is 3n is here, 2 minus 3 is minus 1, everything is equal to 29. So 3n is equal to 29 plus 1, and 29 plus 1 is 30. Divide both sides by 3. When you do that, n is equal to 10. So there are 10 terms in the sequence. Then for number 4 says we should express this in index form. To express this in index form, you have to know the laws guiding logarithm, provided that the bases are the same thing, a and a, and you have addition here, you simply have to multiply. So this is the same thing as calling it logarithm of to base a of x times y, which is xy, and that will be equal to what? 3, because addition is multiplication. Now there is a law of logarithm that says if you have logarithm of a to base b and it is equal to c, that b power c, b to the power of c, should be equal to what? A. Doing the same thing here, a power 3 should be equal to xy. Therefore, you can still write that xy is equal to a to the power of what? 3. So this can be in index form. So, and that's all for today. Expect more videos on other equations. Bye.